The third type of problem we can solve using systems of linear equations is geometry problems. Again, when we're working with systems, we have to have two equations, so keep that in mind. For this first problem, we have a rectangle, it's important to know the shape, that has a perimeter of 34 centimeters. It may be helpful for you initially to draw a picture of this. And what we know about the perimeter is it's the distance around the outside. We have a width, and both of those are the same, and we have two lengths. Again, both of those are the same. That can be written as one equation. We can know that the perimeter equation is P is equal to 2 widths plus 2 lengths according to our rectangle. Then it says that its length is 5 more than, so length is 5 more than twice its width. So we can write another equation talking about our length. The length is going to be equal to, this is our equal word, 5 more than twice the width. So we know we have to multiply the width by 2, twice the width, and it's 5 more than that, so we say plus 5. Again, we can only have two variables, so this P up here can't be there, and that's fine because we know the perimeter is 34 centimeters. So instead of P, we're going to say 34. Now we have our two equations. 34 is equal to 2w plus 2l, and L is equal to 2w plus 5. In this, we have one variable isolated. So because we have one variable isolated, we can use substitution. So we're going to take all of this, everything that the length is equal to, and plug that in for length. 2w plus 5 is equal to, it's the exact same as length, and this length is the same as this length, so we can substitute that in. So what that equation will look like is 34 is equal to 2 times the width plus 2 times the length, and now the length is going to be 2w plus 5. Because this is all one big grouping, we have to put that in parentheses into our equation. So now when we simplify this, we distribute it in. Two times 2 gives us 4w plus 2 times 5 gives us 10. Now we have like terms that we can combine, so we can say that it's 34 is equal to 6w plus 10. From there, we can get our constants on the same side, so we subtract 10, which leaves us with 24 is equal to 6w divided by 6, and we get 4 is equal to w. So we know that the width, in this case, is going to be, we're talking in terms of centimeters, so it's going to be 4 centimeters for the width. That's just one of the dimensions. Then we can plug that 4 centimeters in for width into either of these equations. We're trying to find the length, so I'm going to substitute it in for the equation that's already isolated for length. So the 4 is going to substitute right up here. So that's going to look like the length is equal to 2 times our width of 4 plus 5. Now when we simplify this, the length is equal to 8 plus 5. And the length is going to be equal to 13. So if the width is 4 centimeters, the length is going to be 13 centimeters as well. So now we know both dimensions of our rectangle, both are labeled for which one is which, and have the correct unit. So this would be our answer. You could also double check that by adding 13 plus 13, because we have two lengths, plus 4 plus 4. And in the end, we would get the 34 centimeter perimeter that we need. Let's do one more. This time, we have a rectangle, again a rectangle that has a perimeter of 32 feet. So again, we're going to use that perimeter formula. Perimeter is equal to 2 times the length plus 2 times the width. And in this case, our perimeter is going to be 32 feet, so we can plug that in instead. So we have 32 is equal to 2 times the length plus 2 times the width. That's one equation. Our next equation is going to compare the two dimensions. Its length is 2 less than twice its width. So when we write this equation, we will say the length, L, is equal to 2 less than the width. We always go less than the total. We start with the total, so in this case, twice its width is the total. So we say 2W, and 2 less than that means we need to subtract 2. This order is super important. So again, we have two equations, one talking about the perimeter and the other comparing the two dimensions of our rectangle. Our L, our length, is isolated, so when we have a variable isolated, we can use substitution, and we're going to substitute everything that the length is equal to in for length in our equation. What that will look like is 32 is equal to 2 times all that the length is, because this is a group, again, it's in parentheses, 2W minus 2. All we did was this part right here, so we still have to add our 2 widths in our equation. From there, we can simplify by distributing. We have 32 is equal to 4W minus 4, then plus 2W. Again, we have like terms, a positive 2W and a positive 4W. So we can write that as 32 is equal to 6W still minus 4. That 4 still needs to stay negative. And from there we add 4 to cancel it, leaving us with 36 is equal to 6W divided by 6. We have 6 is equal to W. Again, W in this case is the width. And this time we're talking feet. So we would say that our width is 6 feet. Then we can substitute that 6 in to either of our equations up here to solve for the length. We want the length, so I'm going to use the equation that's already with the length isolated, and plug it in and solve. So this time it's going to be the length is equal to 2 times the width. Our width is 6 minus 2. So our length is going to be equal to 12 minus 2. So our length is equal to 10. Again, we're talking in terms of feet, so we can say that the length is 10 feet. And again, we have the dimensions for our rectangle, the length and the width, so this would be our final answer with all of our work shown.